So, good evening, everybody. Thank you very much for being present here. We will speak in English because we have some students, Erasmus students here. So, this conference is part of the subject of the master program. So, and we have several Erasmus students. So we will speak in English. Thank you for the audience, for all of the presences, and thank you, Inês Almeida, for being here and giving us your cooperating with us today. So I will start with my presentation. So this conference is entitled Transition from 5G into 6G, Challenges and Perspectives. I will speak initially, and the title of my presentation is The Roadmap into 5G, and then Inês Almeida, Professora Inês Almeida will give a speech about the use of artificial intelligence in 5G communications. So, my name is Mário Marques da Silva, professor at this university, Universidade Autónoma de Lisboa. I am the director of the Department of Engineering and Computer Sciences and also researcher at Instituto de Telecomunicações. So the references for this presentation, I have a number of journal articles published which are related to the topics of this conference about 5G communications and 6G communications, namely large intelligent surfaces or large intelligent antenna systems, which is the core business of 6G communications, as well as this article deals also with the use of LDPC codes associated with large intelligent surfaces as well, which is the core. Large intelligent surfaces is the core of 6G communications, as we will see in a minute. So initially, before we speak about 5G and 6G, it's very important to insert the topics within the framework. In the framework where 5G and 6G communications are inserted is the digital transformation, or the fourth industrial revolution. The fourth industrial revolution is the revolution of the artificial intelligence, robotics, robots, artificial intelligence, big data, and Internet of Things. So 5G and 6G play a very important role within the Internet of Things. So give us a contribution to the fourth industrial revolution, because while previous generation focus on human to human communications, 5G and 6G focus on Internet of Things, or of things supports the communication between things, okay, between objects. This is the big difference of 5G and 6G. And it's very important to speak initially a little bit about the fourth industrial revolution for us to understand why 5G and 6G communications are specified as they are, okay? So we had several industrial revolutions. Initially, we had the revolution of the steam, then the electricity, then the revolution of the computers, and finally we have the fourth industrial revolution. The third industrial revolution, which in some part we can say that it has already passed, is the revolution started with electronics, initially analog electronics, then digital analogs, then all over IP, everything inside packets, all over IP. And we speak about the television, about the media, we speak about the computers, all of these technologies supported new disruptive other technologies, the media and the computers. And what happened? We had humans being replaced by machines. In this case, in the case of the third industrial revolution, humans were replaced by computers, by information systems and technologies. Okay, so all of the different revolutions allowed a more efficient use of the resources. And the third industrial revolution, by replacing humans by computers, supported or gave a contribute for a more efficient use of the resources. And when we speak about the third industrial revolution, we speak about the information age. So we are bombed by massive quantities of information, of data, which is data is the encoding of information. And we have many information, but not all of them are truth. That's a different story. And right now, as I have mentioned, we started a new era or a new age, the age of the fourth industrial revolution. Is the revolution of the robots, of artificial intelligence, of big data, and of Internet of Things, things communicating. And this is also entitled automation era, the era of automation, because many tasks are undertaken by robots. And this is also the knowledge age. What is the difference between knowledge and information? Well, information can be true or not true, and sometimes we have many information, but it's difficult to get the information we need to support decision making. And knowledge is the exact information made available at the right time to the right person to support a certain decision making. Okay, right now I need to make a decision, and if I have some tool to generate knowledge, then it's very useful. Otherwise, it's difficult to get the right information at the right time. And nowadays, when we use, for example, the ChatGPT or the BART, it gives us a contribution to get the knowledge, the right information at the right time to the right person. This is very useful. And something that is important to mention is that the difference between the fourth industrial revolution and the previous revolutions, the previous evolutions and revolutions, was that the decisions were always in the past, always all of the decisions were made by humans. Right now, this is completely different from the past, because many of the decisions are undertaken by machines. And we start a new era. This is a huge difference from the past. So this fourth industrial revolution is completely different from all of the previous revolutions and evolutions as well. So when we speak about the fourth industrial revolution, as I have already mentioned, we speak about robots, we speak about artificial intelligence, we speak about huge quantities of data, big data, and we speak about Internet of Things. Let's say Internet of Things communicate, generates massive quantities of data. These massive quantities of data are processed using artificial intelligence, and this artificial intelligence supports, for example, a robot can be, for example, an autonomous vehicle. You have sensors and communications and the Internet of Things, generates large amounts of data, artificial intelligence on board to process and to make a decision, to make a curve, to decrease the speed, to increase the speed, etc., etc. Okay, so artificial intelligence is very useful in automation to control the automation. But we have also 3D printing. 3D printing also plays a very important in the modification of the society. For example, in terms of logistics, we decrease the number of spare parts that we need to store in a shop close to us, because many of these spare parts can be built by a 3D printing whenever we require. Okay, so these will modify the manufacturers and the way objects are stored. We speak also about quantum computing and quantum cryptography. Quantum physics is a very important area of the physics that we it's still under research, and quantum physics is area of the physics that we know what occur, we know the results, but still not known exactly the mechanisms that act over these actions. So there is still many. We know the results, and we can take advantage of these results of the physics of the microparticles, which is the quantum physics. But still, many things are not exactly know why it happens. We know it happens, but we don't know why it happens. Okay. So we, by using these effects of what occurs in the physics of the microparticles, we can build quantum computers. We can implement quantum cryptography, which is very reliable in terms of security. Okay, and in terms of quantum, imagine with algorithms we have right now with artificial intelligence algorithms. Imagine that if we associate these algorithms, this ability to make decisions, to generate knowledge with quantum computers, where the quantum computers we have the processing power increase exponentially as compared to the computers we have nowadays. So if we mix those two items, then we may have, let's say, an explosion of technology, of knowledge, of everything. Okay. So automation, the era of automation, some jobs disappear, other jobs are created. This will have an impact in agriculture and industry, but also trade and services. We will also have some modifications, some adaptations, and lower skills will be more impacted than jobs with higher level of skills. And then scientific, technical, and human skills are more important, more and more important. Like critical thinking is very important. Critical thinking is very, very important. Much more important nowadays than in the past. Okay, the social skills are very important in companies. Emotional intelligence, abstract thinking, all of these assets or these skills are becoming more and more important as compared to with the past. And then with all of these technological advances, the result is that the companies are becoming more and more capital intensive, which means that in the future, eventually, we will have companies, the big companies will, with more power to invest, will increase the competitive advantage as compared with the small companies, because the small companies cannot invest on technology. So the big companies, the ability to invest on technology will make the difference in the future. Okay. So as I have already mentioned, the autonomous vehicle can be viewed as a robot with artificial intelligence and that processes big data, large amount of data, and a car as Internet of Things. And 5G plays a very important role in terms of Internet of Things for these for vehicles autonomous, for self-driving cars. Why? Because 5G was designed for not only to support higher speed communications and lower latency, but also to support communication between objects, between things, between cars. Cars is a special case of the 5G, as we will see in the following. Okay. So the future is now reality in terms of logistics, in terms of smart cities. Smart cities, well, we have millions, or in the future billions of sensors in the city. Even the war, we have unmanned aircraft vehicles making the war remotely controlled, where missiles can be fired from these aircraft. So we have many, we have drones, we have micro drones, even the lawyers and the medical assistants can be supported by machines. And it's a reality more and more, okay? So employability is modifying, as I have mentioned, industry and agriculture will have a higher impact, but services and trade also some impact. Lower skills will have more impact. Younger people will be more subject to automation than older people, because older people typically has more experience and can give a contribution in a different way. So new jobs that will not have so many, are not so subject to this automation, are, for example, everything that is associated to this technology. So it is expected that some jobs disappear, but some new jobs will be created. Okay, and the job market, OECD, OCDE in Portuguese, expects that the job market, the number of employees will continue to rise, but there will be a modification on the job market, which requires from us an adaptation to the new job markets and to the high level of skills. For example, new jobs in terms of generation of technology, of maintenance of technology, operation of and administration of technology. For example, creative intelligence, organizational manipulation, social intelligence, psychology, sociology. All of these jobs are becoming more and more important. Why? Namely because the population is getting older and older. Okay, the aging we are facing in Europe and the United States, aging of the population, which will have an impact. And technology plays a very important role in this new environment. So, what is the world that we will have in the future? We have the world, while the Occidental world experiences an aging of the population. So the people in Europe and the United States is getting older and older, which is a problem, which represents a problem. Represents a problem in terms of economy, because we will have more retired people, then someday we will have more retired people than people able to work. And on the other side, looking at the world as a whole, the population is increasing very drastically. So it is expected that around in 60 years from now, the population will double. Right now we are 8.5 thousand billions, of humans, and it is expected that in 60 years from now, we will be 17,000 billions, which will have a great impact in terms of the way we live, of resources, of water, of goods, of food, of everything, of traffic, of environment, of everything. Okay. And on the other side, we also see that there is an exodus of the population. People is going to live more and more inside cities than in the countryside. And the pressure in terms of immigration, naturally, that will increase more and more and more and more and more. So this is, and on the other side, the globalization will continue to rise. So some people, just for us to think a little bit about this, some thinkers, some people that make some reflections about these subjects, expect that the effect of the borders will decrease. So the globalization and, for example, cryptocurrencies can be the future of the world. Okay. So and when we speak about the fourth industrial revolution, there is a new concept that was invented in Japan, which is the Society 5.0. The Society 5.0 is the integration of society with technology to allow people to live better and better. Okay, so the society will take advantage of technology in a very efficient way to improve the quality of life. This is a concept that is being explored nowadays. And, for example, in terms of population, with impact in population aging, climate changes, urbanization, and resources, it is expected. Let me just tell you that it is expected that due to this increase of population, and due to the lack of resources, it is expected that the people more and more will share resources. Sharing of resources is the key word of the future, instead of propriety. For example, I have a car which is parked in the garage for 97% of the time. I use the car for 3% of the time. And what about if I have an autonomous vehicle, and then I could share my car for the remaining 97% of the time? And this is a more efficient use of the resources. And when we speak about Airbnb, we speak about sharing of properties, for example. So sharing is the keyword of the future. Sharing, more and more. And the Generation Z, people that were born after the year 2000, it is expected that we'll explore this new concept of sharing. So when we speak about Society 5.0, we speak about the several items that we have described in terms of industrial revolution. For example, in terms of total connectivity, so everything is interconnected. We speak about using more and more data. Since everything is connected, we have big amount of data. We have big data. We speak about artificial intelligence. We speak about automation. We speak about personalization. We speak about solving complex problems, and we speak about a reduction of the carbon of CO2 through the use of technology. And we speak about when we speak about Society 5.0, we speak about active participation of citizens. Okay, active participation of citizens is encouraged within the framework of Society 5.0. So when we speak about technology, we speak about also about the environment, okay? So the technology gives a contribution to use the environment in a more effective way. How? For example, when we speak about mobility, we speak about electric cars. Nowadays we speak about hydrogen. What is hydrogen? Hydrogen is electricity that is used to generate hydrogen, and then a car that is moved with hydrogen is a car that uses hydrogen to generate electricity. It's an electric car. This is an electric car that uses hydrogen to generate electricity. Okay, so hydrogen is generated. Hydrogen is generated in aeolics, for example. It's generated from the electricity, and the car that uses hydrogen. Hydrogen is used to generate electricity, and it's electrical car as well. Okay, so it simply replaces the batteries. So this is a way. And we speak about mobility, we also speak about car sharing. Car sharing, once again, the future of mobilities. So if you want to use the resources in a more efficient way to avoid the reduction of the carbon footprint, then mobility, car sharing plays a very important role. So renewable energies also rely on technology. So we need technology to generate industries, more efficient energy industries, logistics as well, smart cities, the more environmental friendly, also rely on technology, more and more technology. So the technology plays a very important role in the implementation of cities that decrease the carbon footprint. Telework or remote work is also reduces the movement of workers every day, and e-learning. So e-learning is also or distance learning or electronic learning is also very important because it can also allow people that lives outside of the cities to gain access to the knowledge, to gain some new skills, and also for some people that may eventually avoid moving every day to the school. And when we speak about e-learning, we speak also about multimedia contents. But the future of e-learning is nowadays we can think about the future of e-learning not only with multimedia contents, but with artificial intelligence. And by using artificial intelligence, we can have this machine can be a professor we can have a professor for each different student, which is a change of paradigm of the way we teach nowadays. It can make a huge difference in terms of future because we can have personalized teaching, which is very important because each student learns has different requirements in terms of learning, and artificial intelligence will have a great impact in terms of this personalization of the teaching learning process, okay? And the evaluation as well, because nowadays we need to find new ways to evaluate students because all of the information, many information can be taken from ChatGPT, Bard, etc. So we need to evaluate the students more and more, not so much about reading what was given to us, but questions and answers, okay? Presentation, oral questions and answers. This is the paradigm, okay? And we speak about robots that also facilitate the telework. And so just very quickly, since Ines will address the artificial intelligence topics associated to 6G communications, just to introduce a little bit of artificial intelligence. So it was invented in 1956, and it was birthed recently with increasing of processing power and with increase of data, big data that can be processed by the learning algorithms. And also with some new algorithms that were, or new learning processes that were invented nowadays, for example, neural networks. And but is also associated to the impact of the decisions. So we have machine, as I mentioned, the fourth industrial revolution is completely different from the previous because the decisions are undertaken by machines instead of by people, more and more. For example, aircrafts nowadays, they avoid collisions while they are in the air. It's the machines that they communicate one to each other, and then they decide what are the attitudes, what are the bow, what are the changes in terms of altitude and direction to avoid the collision. And these are this is completely autonomous. This is made by the aircrafts, not by the pilots. Okay, and we see more and more this being undertaken. Okay, autonomous vehicles is almost a reality. And so when we speak about these decisions, there is not so much the artificial intelligence nowadays focus on the inputs. So we have several inputs and we need to make a decision based on the inputs. But it is expected that the next generation of artificial intelligence also takes into account the impacts of such decisions, taking into account ethics values. Okay, this is very important. For example, the train's dilemma is a train, for example, is known in artificial intelligence as a train that there are two lines, and if it goes through one line, it will kill one old people, and if it goes to the other line, it kills one younger person, and it has to decide, or one rich person against one poor person, one very intelligent person against one not so intelligent person, for example. And this is an ethical issue, okay? That this is the impact of the decisions that humans take into account, and the machines is also a problem in terms of this impact. This is known as the train's dilemma. So very quickly, artificial intelligence algorithms. We have a number of algorithms, the learning algorithms, the supervised learning, where data is classified. So we teach the machine, and then the machine learns what is a dog and what is a cat. And when afterwards, when it sees a dog and a cat, it's already the machine is already able to identify a dog and a cat because we teach the machine. This is called supervised learning, and then we have unsupervised learning, where there are some algorithms. It is able to classify data autonomously. For example, Spotify musics based on the beat. For example, it classifies the music. Reinforcement learning widely used in autonomous vehicles, where there are a set of rules, and when the robot follows the rules, it gains some points, and when the rules are not implemented, it loses some points, and then it's a kind of a game that the robot wants to maximize the number of points that are awarded. So. And finally, the deep learning uses artificial neural networks interconnected through synapses, and it replicates the human brain to recognize data as well, and to put into baskets different. And then nowadays, when we speak about ChatGPT and we speak about BART and many other artificial intelligence, we speak about generative learning process, where it gives, when make a question, it gives a response that is more statistically correlated with the words of the question. And for example, when I ask the ChatGPT, who was the author of the book entitled Cable and Wireless Networks? Me. But the ChatGPT always, the answer is always cable and wireless networks was the question. It goes, it searches, and there is a researcher in the Netherlands that have many publications, more publications than me, than I, associated to cable and wireless networks, to these words. And then always when I ask who was the author of the book Cable and Wireless Networks, this gentleman was the author. So always the same. So why? Because the answer is based on the words given in the question. And since this gentleman is more associated to cable and wireless networks words, the answer is not correct. So be careful with ChatGPT and be careful with BART, because these algorithms are not 100% reliable. The algorithms work based on statistical correlation of words. Okay. So 5G. Now we start the core of this subject. So the cellular concept started on the 80s with the analog, the first generation analog, and then typically every 10 years we have a new generation of cellular communication. So 80s the 1G, GSM, which is the second generation on the 90. Then 3G on around the year 2000, and then 4G around 2010, 5G 2020, and 6G is expected by 2030. And as I have already mentioned, so the first G is analog, second G already introduced some level of data, already digital with ability of roaming. This is already with the SMS short messages data, very low data rates. 3G brought the internet and the access to some media. 4G also supported video teleconferences, and 5G Internet of Things, the change of paradigm, because not human communications, but human communications plus object communications. 5G communications between vehicles support smart cities, for example, smart logistics, remote surgeries, etc., etc., etc. And 6G follows this paradigm in a more efficient manner. So 5G is disruptive because communications can be established through a base station, but can be also established without a base station. For example, when we have two vehicles that are in the road, not covered by a base station, and in this case, the latency is very important. They communicate directly without a base station. Okay, so this is very important. 5G disruptive because Internet of Things, and because they can communicate not through a base station. Can communicate through a base station, but can communicate also in some situations without base stations. So this is completely different from the previous generations. And we have naturally with low latencies, higher throughputs, more efficient use of the spectrum. So the spectral efficiency increased, which means that bits per second per hertz are higher than in the past. More efficient use of the spectrum. And when we speak about 5G, we have three different use cases. The first use case is entitled Enhanced Mobile Broadband. And enhanced mobile broadband is the regular type of communications, typically human communications, but at higher speeds as compared to 4G. And then we have the second use case, which is entitled massive machine type communications. And this is very important to support communications between sensors, for example, when we speak about smart cities where we have millions or even someday billions of devices in smart cities. And these sensors are interconnected through 5G, okay, through using this use case of smart logistics. And these kind of communications are very low data rate and low power communications, very low data rate, but many high number, the number of devices is extremely high, okay? And then the third use case is entitled ultra reliable low latency communications. Ultra reliable means that for example, to support autonomous vehicles or to support remote surgeries, these kind of services require ultra reliable means that they cannot fail. Ultra reliable, they cannot fail. Otherwise, we have a car accident, or otherwise someone dies during a surgery. Okay, low latency communications, because latency means that if you have a latency, two vehicles are approaching, and if there is a latency of 1 or 2 or 5 seconds, then an accident may occur. And even worse in a remote surgery. So ultra reliable low latency communications is the use case that focus on these very sensitive services. And the 5G communications initially was implemented in each 3GPP release 15. The baseline, based on 4G base stations as an upgrade, and then the 3GPP release 16. Initially, the release 15 focused only initially on the enhanced mobile broadband, okay? Communications, humans, let's say. And then when we speak about 3GPP release 16 afterwards, the new version, the new evolution, we focus already in the other two use cases entitled massive machine type communication, the ultra reliable low latency communications. And these different use cases are implemented using the so-called network slicing. Network slicing is the reservation of resources for different services, okay? So these three different use cases with different requirements are possible to be implemented because there are some reservation of resources implemented with network slicing. So the network is sliced, okay, like a cake, and in terms of resources, okay? And then the 3GPP release 17 focus on the new version of the ultra reliable low latency communications, and for example, in remote control of vehicles. And you may ask, but what about the implementation in Portugal? Everything is already implemented, and the answer depends on the operator. Depends on the operator and depends on the area. For example, in Lisbon, for example, some operators, Vodafone already have ultra reliable low latency communications implemented in Lisbon, not in the rest of the country, for example. For example, it depends on the operator and depends on the area. Okay. So when we speak about 5G communications, the two most important ingredients of 5G communications are massive MIMO systems. MIMO systems means that we have multiple input, multiple output, which means that we have multiple transmit and multiple receive antennas, and we have parallel flows of data. By using these concepts, we can implement instead, let's say that instead of having, if we have 10 transmit and 10 receive antennas, if between each transmit and each receive antenna, let's suppose we have 1 gigabits per second flowing. By having 10 transmit and 10 receive antennas, we have 10 parallel or flows of data. We have 10 gigabits per second, and this is a mechanism that is used to increase the throughput, increase the simples rate. Okay. The other very important ingredient is millimeter wave communications. Millimeter wave communications means that instead of using the spectrum, the centimeter wave communications, using the traditional frequencies around 3 gigahertz, by using millimeter wave communications, we use spectrum between 60, 70, or 100 gigahertz, and this presents a higher coherence channel bandwidth, which supports much higher throughput. In addition to this, higher frequency corresponds to a lower wavelength, which means that MIMO systems, the size of antennas are lower, and the distance between antenna elements is also low. I will address this issue in the following. So we speak about 5G. We speak about also about security aspects. There are some issues in terms of security. So when we speak about Internet of Things, we speak about things communicating, communication of things. For example, we speak about webcams, smart TVs, loudspeakers, refrigerators, smart lockers, vehicles communicating. And the computer, in terms of cybersecurity, my computer is properly protected with antivirus and firewalls, etc. What about this? Do you have your loudspeaker is properly protected? This represents an input to the 5G network, okay? And with low latencies and the high speed of communications that of 5G, the vulnerability is so the system is more subject to is more vulnerable. And on the other side, when we speak about 5G communications, we speak about billions of devices. And when we speak about billions of devices using the IP protocol, then we have a problem in terms of address spacing. Address spacing can be a problem because IPv4 is depleted. And to solve this problem, instead of using IPv4, we use IPv6, which has an address spacing of 128 bits instead of IPv4, which is only 32 bits, completely saturated, depleted. And when we speak about IPv6, we speak about something that is typically embedded, which is IPsec, IP secure. IP secure, we have two different in terms of security, gives protection. So when we speak about Internet of Things, we speak about IPv6. IPv6, we speak about IPsec. IPsec has two different mechanisms or two different modes of operation. One is authentication header, which gives us protection from attacks against authenticity and integrity. And the other is encapsulation security payload, ASP, which is in addition to the authenticity and integrity, it also gives us protection that attacks against the confidentiality. Okay. So in terms of radiation, there are a number of legislations, national, international, from the European Commission, from the International Telecommunication Unions that protects us. One of the problem, for example, some people have special concerns about these millimeter wave communications, so everything is properly protected with legislation that are in place. And when we speak about security, we also can address the problem of the communications of the force and security of the forces and security services, policies, fire protection, and even militaries. Okay, and can we use 5G for that? Eventually, yes, because when we speak about forces and security services, we have in Portugal we have the Ciresp. Ciresp is based on a European standard called Tetra. Tetra is similar to GSM, is a second generation standard based on TDMA, exactly like GSM. And this is so the data rates made available are very, 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 very low, with very limitations. So the network is saturated very easily, especially when there are some operation, when there is a fire, and it's very, very typically the system, the network collapses, and many limitations. So some countries are already exploring the Internet of Things capability of 5G communications and the additional properties of 5G. Some countries are already using 5G communications for these forces and security services, because it supports, for example, ComSec, communication security, is implemented in 5G using ASP, using the IPsec, as I've already mentioned. The direct mode of operation we don't need to have a base station to establish communication, which is a requirement for the forces and security services, and 5G supports this direct mode of operation, multicast and broadcast, priority of calls and fast setup. All of these requirements are in place in 5G. So why not to use 5G communications instead of this old-fashioned Tetra, which when we need to use them, it does not respond properly. So just for us to think a little bit about this. So the network slicing, once again, make some reservation of resources. Why not to reserve some resources using the commercial networks, or using some part of the network, not commercial, but from the government, to support these forces and security services, for example, during the firing operation. So when we speak about spectrum, about increased data rates, we have a problem, because this is not only a matter of spectrum. If we need high-speed communications, means that increasing the data rates, we also increase the symbols rate. When we increase the symbols rate, we increase the worst enemy of wireless communications, which is called intersymbol interference. So if I want to increase the symbols rate 10 times, we also increase the intersymbol interference 10 times. Then it's a big problem. How can we mitigate this increase of intersymbol interference? How can we increase the symbols rate? How can we increase the data rate without, while mitigating the intersymbol interference? This is the response is using in 5G communications, and 6G as well is exactly the same. In a more efficient manner, is using MIMO systems, multiple input, multiple output. Okay, so if we have 10 transmit and 10 receive antennas instead of one, we increase the throughput. We have 10 parallel symbols flowing between the transmitter and receiver, and each one has a symbols rate 10 times lower. So we don't increase the intersymbol interference. Okay. And this is a multi-layer MIMO system, spatial multiplexing, where the number of is a specific type of MIMO system where the number of each transmit antenna sends a different flow of data. There is a serial to parallel conversion of data, and each transmit antenna sends a different parallel, different stream of data. And we require that the number of receive antennas needs to be equal to or higher than the number of transmit antennas. And by using algorithms such as the VBLAST algorithm or the successive interference cancellation, we can extract each of the different streams that are being transmitted by each of the transmit antennas. And this is space division multiplexes. This is the difference, the opposite of what we were mentioning, that we have different mobile stations, and all of the different mobile stations are transmitting at the same frequency at the same time. And by using, exploiting the same concept, the receiver, the base station, has a number of receive antennas equal to or higher than the number of mobile stations, and through the same algorithms, namely VBLAST algorithm, can extract the data being transmitted by each one of the different mobile stations. And this is the beamforming. Beamforming means that we have, while in the previous MIMO systems, the distance between adjacent antenna elements is of the order 3 to 4 wavelengths for the signals to be statistically uncorrelated, which means that if I have a deep fading here, I don't have a deep fading over there, because the signals need to be sufficiently spaced apart such that the signals are statistically uncorrelated. Okay, so 3 to 4 wavelengths typically depends on the environment. When you speak about the beamforming, we also have different antennas, but these antennas, to be able to form a beam, this is electronically generated, and typically the antennas are spaced apart half wavelength, not 3 to 4. So there is some level of correlation between adjacent antenna elements, okay? And they are properly weighted such that the beam towards in the direction of the receiver we can direct the beam towards the receiver, mitigating the leveling of interferences to the other receivers that are not in that direction, and maximizing the energy to the desired receiver. So this is a multi-user MIMO. I'm not going to address this multi-user MIMO. And this is another mechanism that can be implemented, OFDM, orthogonal frequency division multiplexing. OFDM is a mechanism that was implemented in LTE, in 5G, and is also implemented in 6G communications, where also to mitigate the intersymbol interference. So instead of sending, let's say 10 gigabits per second, we can split the spectrum in 10 10 slots, and each slot sends 1 gigabits per second, let's say, or 1 giga symbols per second. And by using this, we also decrease the symbols rate, and consequently, we decrease the inter-symbol interference, taking into account that different subcarriers are not exactly like that, but they are implemented using inverse discrete Fourier transforms, and there are some level of overlapping, and they maximize the use of the spectrum while not having the way they are implemented. Although they have some kind of overlapping, there is no interference between them. Okay, this is the way they are. OFDM is implemented. And when we speak about 5G communications, as I have mentioned, the two most important ingredients are millimeter wave communications, which means that we use higher carrier frequency. For example, at home we have Wi-Fi, and Wi-Fi we have the 2.4 and 5 gigahertz frequency bands. We have two different. What is the advantage and disadvantages of these two frequency bands? 2.4, the coverage is higher. Why? Because the propagation losses are lower as compared to the 5 gigahertz. So, higher frequencies have higher propagation losses, which means that the coverage is lower. So 5 gigahertz, the coverage is lower, but the throughput is higher. And why is it higher? Because higher frequencies present the so-called higher coherence channel bandwidth. This coherence channel bandwidth means that it is the bandwidth inside which the fading is not frequency selective fading, and therefore we can use without having an impact in terms of inter-symbol interference, let's say. Okay, and fading. The fading is under control. So by using a higher carrier frequency, we have less interference, which means that it can support higher symbols rate, higher throughput. This is the advantage. So 5G in Wi-Fi at home that we have at home support much higher throughputs than 2.4, but the coverage is much lower. And this is exactly the same. When you use millimeter wave communications, it means that we use frequencies instead of 3 gigahertz, we have frequencies of 60, 80, or 100 gigahertz. And the throughputs, the bandwidth that is supported is much higher. The throughputs are much higher than in 3 gigahertz. But the coverage, the range is greatly decreased. Okay? And when we use frequencies much of 60 gigahertz, for example, means that the wavelength can be of the order of 5 millimeters. 5 millimeters means that, let's suppose that we have an antenna that is half wavelength, means that the size of an antenna is 2.4 millimeters. Okay, means that I can, in my mobile phone, I can have dozens or hundreds or even thousands in some situations of antennas. Depends on the carrier frequency. And on the other side, if the distance between antennas is of the order 3 to 4 wavelengths, means that by using a higher frequency, I can also support more number of transmit and receive antennas, so I can implement the MIMO in a very efficient way, in a more efficient manner, using high frequencies than lower frequencies. Okay. And you can say, but there's a problem in terms of higher propagation losses. Yes, we can use beamforming, for example, beamforming to maximize the beam towards the desired user. So 6G communications. 5G communications focus on the initial requirements of the fourth industrial revolution, as I have already mentioned. So the fourth industrial revolution is basically initially implemented by 5G, Internet of Things paradigm. And what is the aim of 6G communications? The aim of 6G communications expected by 2030 is to improve such implementation, because we expect that we will have more and more Internet of Things devices. Smart cities will be a reality with more and more devices, smart logistics, autonomous vehicles, holographic services. Right now we are transmitting through Zoom, but one of these days we will have an holographic services instead of Zoom, for example, 3D video teleconference, and the throughputs that are required increase drastically. So we need to have so new services will be implemented, improve autonomous vehicles, smart cities, smart houses, augmented reality and extended reality, support of flying vehicles, and increased mobility speed. Okay, and there is a rule of the economy that states that the increase of demand originates an increase of the offer. But also there is also another rule of the economy that says the increase of the offer made available by 5G will originate an increase of demand in terms of new services that will appear as a result of the new requirements that will be made available by 6G communications by 2030. Okay, so so what is expected in terms of requirements? In terms of requirements, we expect to have peak data rates of the order of 1 terabits per second with 6G communications. While in the mobile environment, 1 gigabits per second, we have with an energy efficiency 10 or 100 times better than 5G, spectral efficiency, that is the number of bits per second that is supported in each hertz of the spectrum, will increase 5 or 10 times as compared to 5G communications. And we expect to use not only millimeter wave communications, but even higher frequencies such as terahertz bands or visible or even visible light communications. So the spectrum, the carrier frequencies that will be used are expected to be even higher than those used by 5G communications. Once again, because higher frequencies have higher channel coherence bandwidth, supporting higher bandwidth, which brings a great added value in terms of implementation of these requirements in terms of namely throughputs. Okay, and in parallel to the use of higher frequencies, we also expect to use extremely behind massive MIMO system. What is behind massive MIMO system? In 6G environment, we call it large intelligent surfaces, LIS, or large intelligent antenna systems, which is a huge panel. Let's suppose is a huge panel on the wall, for example, with thousands of antennas. Okay, thousands of antennas like this, and each one implementing a special type of beamforming. We have seen the beamforming where the antennas are spaced half wavelength, but this is a short range beamforming using line of sight communications. And this is a very low cost antennas that are being researched, and this is a very low cost panels that will be in the market very easily. Okay, there is already technology to implement this in practical manner. So the two ingredients for 6G communications is large intelligent surfaces, the LIS systems, as well as terahertz bands are the two most important ingredients for that. So what is the large intelligent systems? Large intelligent systems is line of sight communications. It's a kind of near field communication because traditionally communications are established behind the so-called Fraunhofer distance. The Fraunhofer distance, while the large intelligent antenna systems, we have a big panel here, and the communication is established in the near field. This is a near field communication which give us special properties that can be exploited by these large intelligent antenna systems. Namely, when we speak about beamforming, we can direct the beam in terms of azimuth, in terms of elevation. We have two degrees of freedom. But if we have a short range or near field beamforming, which is made available by the large intelligence antenna systems, we gain a third degree of freedom, which is the possibility to direct the beam not only in azimuth and elevation, but also in terms of distance. We can see this, for example, like a lens that we take the rays from the sun and we can open fire in a paper because the distance, as long as we place the distance at the proper focal distance. And the large intelligent antenna systems also supports this, because which means that we can, for example, establish communications with one person that is, if we have two persons at the same azimuth and the same elevation, but at different ranges, I can focus the energy on one of these without generating interference on the other, that is on the other user that is aligned with the first one. And this is very important, especially when we have many, and when the number of devices increase drastically. Okay, so this is a concept of the large intelligent antenna systems that I think Inês will also address a little bit. So some results, just to finish, some results for large intelligent antenna systems, LIS, or large intelligent surfaces, also known as large intelligent surfaces. So we study we study the bit error rate as a function of the signal to noise ratio for LD with and without very efficient codes entitled LDPC codes. We consider an environment 5 statistically independent equal average power paths in different types of receivers, zero forcing, minimum mean square error, maximum ratio combining, equal gain combining. And the number of users we consider in our examples 2, 5, and 10 users. And LIS composed of 4 panels of 25 antennas versus 225. So we have a comparison between those two. But, for example, what do we see? We see that the bit error rate is a function of AB over NO. So that is the bit rate, the probability of error as a function of signal to noise ratio. And we see here that the zero forcing and the MMSE perform better than the maximum ratio combining and better than a equal-gain combining. Okay. Nevertheless, these two receivers, the zero forcing and MMSE, requires the channel inversion for each channel component, for each component of the channel. The matrix inversion for each frequency component of the channel, which is in terms of processing requirements very demanding. Okay, so these two receivers require the channel inversion for it. The matrix inversion for each channel, for each frequency component of the channel. This is very demanding in terms of processing, while the MRC and EGC are very simple receivers that do not require this channel inversion or matrix inversion. Here, what we see results for two panels with 225 instead of 4 panels of 25 antennas each, and we see that the performance increases drastically by increasing the number of antennas, antenna elements. The performance increases drastically, and the MRC is already closer to the EGC and the MMEC. And here we see this graphic shows results with 4 panels of 25 antennas against 4 panels with 225 antennas each. And we see that increasing the number of antennas as expected, the performance increases. Nothing. Here we see that as the number of mobile terminals increase to 5 or 10, the performance decreases. This is what we can see from this graphic. When we increase, as expected, when we increase the number of users, the level of interference increases and the performance degrades. So the best performances are achieved with 2 users, and the worst is achieved with 10 users. And here we see the results with and without LDPC codes. The LDPC codes are very efficient codes. And we see that with LDPC codes, the results are much better than those without LDPC codes. And finally, as a conclusion, we have seen an advantage of the LIS, the Large Intelligent Antenna Systems, which relies on its good performance and simplicity. And we can performance improvement increases with the number of antennas and with LDPC codes. We have seen that, and decreases with the number of users. And we have seen that although in some situations, MRC and EGC receivers perform almost very close to the zero forcing and MMEC. The performance is not so good. So in some scenarios, the performances are closer, but present the advantage that they do not require these receivers, these very simple receivers, do not require the inversion of the channel metrics for each frequency component of the channel. So which is, and we have seen that the system comprises of a LIS associated with LDPC codes and coupled with SCFD transmission, which we were considering in these simulations, exhibits performance optimization that improves with an increased number of antennas. And this is for those that make research on the area. I'm the guest editor for this special issue of Applied Sciences MDPI that you are invited to to submit articles. And finally, I finish with this permanent change is the only constant in the world. So which means that nothing is constant except the permanent modification. And thank you very much. So I will transfer the floor to Inês. Inês will speak a little bit, and then the floor will be yours for questions and answers. Okay.
So good afternoon, everyone. We just had an amazing talk about the roadmap into 6G communication with Professor Mário Marques da Silva. Thank you so much for that. So right now we are ready to talk about another innovative topic. Okay, so let's start. I'm Inês Almeida. I'm professor at this university, and I'm also doing my PhD thesis at Nova University about deep learning applied to channel estimation. Okay. So today I will talk about artificial intelligence and its application on 6G communication. Okay. I will talk first about what is artificial intelligence, next about the application of AI on 6G, and finally, let's talk about some challenges. Okay, so let's start with a quick brainstorming, and I need your help. Okay, so we will create a cloud of ideas, and I want you to scan this QR code and tell me what is artificial intelligence for you. Can you do that? Very quickly. Okay, what is artificial intelligence? Describe it in one word, please. Yeah. Let's see some of your answers. So let's see. Okay, perfect. We have how to mimic human brain. Okay, we start, like I usually said, so far so good. Innovation more. Can you think more? I'm waiting for you. Smart, automation. Anything else? What is artificial intelligence for you? We have future for humans, okay. Automation, how to mimic human brain, smart, innovation. So far, so good. It's a good step. It's a good beginning. So let's dive into the AI definition, okay? Thank you all for your response. Thank you. Perfect. So let's continue. And this guy is John McCartney and is one of the co-founders of AI. And he defines it as the science and engineering of making intelligent machines, especially intelligent computers, programs. It is related to the similar task of using computers to understand human intelligence, but AI does not have to confine itself to methods that are biological observable. So this means that AI combines both theoretical approach and practical application to create machines that can think and learn. But it's much more than replicating human intelligence, you know, it's much more than that. It's creating innovative ways to process information, and resolve problems, okay? So, for that, AI operates by recognizing patterns, okay? So one of the key aspects of AI are patterns. For instance, AI algorithm or AI system can identify a car by the common features like their windows, their wheels, and so on. So AI based on patterns. But for that, we need data. And one other key aspect of AI is data. So an AI system is trained to recognize patterns through data exposure. We need data. We need a huge amount of data. And the algorithms will learn through this data exposure. So the more data we have, the better an AI algorithm becomes to identifying and predicting some patterns, okay? So, and let's do something interesting, okay, to better understand how AI is important and what AI is capable of. So, I'm about to show you a video, okay? And in this video, you will see a lot of cars moving fast. What I want you to do, I want you to count the number of cars that you see. Can you do that for me? Yeah? Let's see. So, any answers? Mash, can you tell me how many cars that you count? 40, okay. Did anyone get the same number? 67, okay, probably, I don't know. So why? Okay, so now I want, so right now you tell me some of your numbers like 40 and so on. Now imagine an AI system that is capable to recognize cars, okay? Its response will be more accurate than our answer. Why? Why? Because he doesn't get tired, we do, okay? We as humans get tired, okay? This video tired us, okay? And AI system can process a huge amount of data. We don't. So with AI system, we can create a system that is capable to recognize cars in an easy way. Why? Because an AI algorithm can process a huge amount of data and is a machine. It never gets tired, okay? So right now we are ready to go to AI application of AI in 6G, okay? So we are in 5G, let's jump to 6G, okay? So it's expected that 6G will be 100 times faster than 6G communication. And we have a lot of applications like Professor Mario already said to you. We will enter in a new phase of communication. But in terms of AI, what it means. So imagine a 6G network, okay? What is a 6G network to you? It's not just a pipeline of data where data run faster. It's not just about speed. 6G network, it will be a network that can learn, that can adapt, okay, that can think, okay? It's a network that have brain. Why? It's a network that can adapt through the user's needs, to the user's needs in real time. So for that, we need AI algorithms. AI algorithms are the support for the 6G communication to be adapted, to be according to the user's needs in real time. So with AI algorithms, we can, 6G networks can tune in real time and can processes a huge amount of data smartly, okay? Imagine a whole city interconnected, okay? A whole city, like cars that communicate with traffic lights, like doctors that receive updates of their patients through their smartphones and so on. We need interconnection, and for that we need brain. So we need AI. Okay. So AI is the key to 6G in terms of interconnections, in terms of communication. With AI, we can create a network that have a brain that can adapt to the users. So this is how it works. I know it's quite complex. I will make it easier for you, don't worry. So what is happening here? So AI is like a brain, okay? Think AI like a brain. We have lots of algorithms like supervised learning and unsupervised learning, like Professor Mario already said to you. And these AI algorithms are capable of making decisions and process data, okay? The heart of these systems are powerful computers, let's say, and storage units that can collect this data. And through this data, AI algorithms can make decisions like reroute the traffic, when to avoid jam, and so on. So we have AI algorithms. We need data for that, and we have certain servers, certain resources to collect this data. Based on this data, an AI algorithm can make a decision. Okay. We have a lots of AI algorithms, but the basis is this. Okay. They make decisions. They are the brain of our networks, okay? So what are the challenges about this? The first challenge is AI is not perfect, okay? AI is not perfect. AI can make mistakes, okay? And we have to be careful about that. And like Professor said, we have to look at data, but also to the impact of data. So here I highlight as challenges the security and privacy. We should have more attention, a lot of attention with security and privacy, because for AI algorithms to work, we need a huge amount of data, and we have to be careful with privacy, security, and also with ethical problems. And then we have to have the capability to process this huge amount of data in real time. So we have to have the resources, the correct resources to do that. So as challenges, I highlight the privacy and the challenge of process a lot of huge amount of data in real time. Okay, so thank you. I hope you enjoyed this presentation, and you get quite a good concept of AI. And thank you so much.
Now, the floor is yours. So questions and answers, comments. Yes, Tomás. Always very participative.
Where and how do we get the information for the AIs?
Where and how do we get information for AIs?
Yeah.
Well, I think the information for AIs, we need to have data, right? Isn't it? So we need to have data. AI systems make decisions based on data, and we have more and more data as the time goes. We have more and more amount of data is always generated, is being generated instantaneously, because we have more and more IoT devices, and we have more and more sensors. We have more and more machines. Everything is generating data, and this is the data. So AI needs big amount of data. This is big data. The so-called big data is huge quantities of data that feeds the AI systems. And so this is correlated with IoT devices. So when we speak about 5G communications, or even more 6G communications, we speak about high quantities of data. High quantities of data feed the AI system to make decisions, to generate knowledge, and to make decisions. Some knowledge is only for as information, and AI systems in some situations give us, let's say, the counseling, only counseling, only some advice for us to make the final decision. In some other situations, is the AI system that already makes the decision. For example, let's think about autonomous vehicles. It's the decision is made by AI that is on board the car. So all of the data is generated in a car. For example, we have sensors, radars, lidars, which is a light radar based on light. We have sensors. And we have cameras, and all of these, and we have the cars communicate one to each other. All of these data that surrounds the vehicle is stored on board in the form of data, and AI system takes the data and processes, correlates, makes fusion of the data and generates knowledge. And then the car speeds up, brakes, turns left, turns right, parks, whatever.
So in regards to Simulation 5.0 developed by Japan, one of the things that you were saying is that in order to be more efficient, we will use share resources. Like you gave the example of your car, with you only 90% of the time it's in your garage, only 7% of the time is being used. But what I'm curious is, how can we be sure that, for example, if we have one car for various people, how can we be sure that these other people won't break our car? Like, how can we be sure that people will use these resources ethically, not just destroy it?
Yes, so this is a risk. Eventually, some insurances will be in place to cover these kind of situations. I think there is no one is sure that it does not, but eventually you could install cameras on board the car, for example, to monitor everything, and with cameras with artificial intelligence properly configured, such that in some situation occurs, then it is recorded that something happened, something was broken, and gives you an alarm that it occurred, for example, or eventually there are some new kind of insurances to cover the. But this is the future of the world, because since the world is the population is increasing very drastically. If we compare the number of people in the world, let's say 60 years ago, it was the world population was much less than half of the population that we have nowadays, and it is expected that in 58 years from now, or 60, some people say it's 58, some people mentions 60, 70 years. We don't know exactly, but more or less. Because we have the population, the world population is increasing drastically, namely in the Middle East, in Africa, in South America, in Asia is increasing, in India, Bangladesh is increasing drastically. The population is increasing, while in Europe and in the United States, the population is the number of people is more or less static, while people is there is a problem of aging of the population. People is getting older and older, which will bring a problem in terms of people to work. So it's not only a problem of paying the retirements; it's also a problem of people able to work, which will have an impact in terms of economy. So I don't know what is the solution for this. What I know is that the immigration pressure will continue to rise and to solve this problem, and also eventually the populism and nationalism movements will try to exploit this problem. That's it. So if we have no more questions, thank you very much for the audience, for your presences, for your participation, for those present in person, and for those remotely present remotely. Thank you very much. Inês Almeida, it was a pleasure to be here with you. It was very, very good. Thank you for your collaboration as well as always. And thank you. We will be back with some more subjects. We have two subjects to bring here. One of the subject is about artificial intelligence only, with a different professor, and we will address the issue of using 5G communications to replace the currently used Tether system in CIRESP, which is very important to make a reflection, to think about this replacement of systems. So thank you very much for your presence, and see you next time.